Today I'm going to talk to you about IB subtopic 5.4, which is all about 3D geometry and the distance between points on a solid. So let's just jump into this thing. The diagram shows a square-based pyramid. E is vertically above the base, O. The height of the pyramid is 1.5 meters, and the sides of the base are 0.6 meters. And since it's a square, these are all 0.6. Find the length of AC. So AC is this diagonal here, just like this. And we can find that if we assume that this is a right triangle here. So A is going to be, we can just use the Pythagorean Theorem. We can say it's the square root of 0.6 squared plus 0.6 squared. And so when I type that in the calculator, I find that the length of AC is 0.849 meters. It's three significant figures. To find ED, the slant height there, I'm going to try and visualize another right triangle. And the right triangle I'm going to try to visualize is from O to E to D and O to D. So I know the length from E to O. They tell me that is 1.5 meters. And I actually know the length from O to D as well. It's just going to be half of what I got right here, that 0.849. Cut that in half. So to do the Pythagorean Theorem here, this is the hypotenuse. We're going to do the square root of 1.5 squared plus whatever half of 0.849 is squared. So when I type that in my calculator, sec square root 1.5 squared plus 0.489 divided by 2 squared looks like the length of ED is 1.56 meters to three significant figures. And finally, part C is EM, where M is the midpoint of CD. So from E to M, that's that height. That's the distance from E to D. So that's another right triangle there. And that's this one. It's kind of hard to see. So let me just draw it right here. E, O, and then we'll call it M. I'm trying to find the distance from E to M. I know the distance from E to O. That's 1.5. And from O to M, it's just half of this side since it's the midpoint. So it's just 0.3. So then it's just the square root of 1.5 squared plus 0.3 squared. And when I do that in the calculator, it's going to be 1.53 meters to three significant figures. So everything we're doing here, when we're doing the distance between 2 points, since we're always dealing with square prisms, square pyramids, that sort of thing, it's always going to be the Pythagorean Theorem, because we're always going to have right angles, which is what makes these calculations pretty nice. The next one here, the diagram shows a cone with a base center of O and a radius of 4. The slant height of the cone is 9. Find the height of the cone. Hopefully you see that this is a right triangle, since this is a right cone. And all we got to do is use the Pythagorean Theorem here. The height of the cone is just going to be 9 squared minus 4 squared. And we subtract them because the 9 is the hypotenuse. So the height, OV, to three significant figures, is simply 8.06 centimeters. Let me show you some of the IB problems that I've seen in the past that you're likely to see something similar in the future. In the following diagram, ABCD is a square. That's important to know this is square, probably. Square base of right pyramid with vertex V. The center of the base is O. The diagonal of the base is 8 centimeters long. Sloping edges are 10. Write down the length of OV. So if I'm trying to find the height of this thing, and I want to use this right triangle that I'm drawing right here. And it sometimes helps to draw it off on the side, which is what I'm going to do. So I've got my O, my V, and my A. I'm trying to find the distance from O to V. I know the distance from V to A. It's just that slant height. It's just 10 centimeters. I said slant height. I meant the sloping edge. And from O to A, it should just be half of that 8. So that's just 4. So the length of OV, if I'm going to use the Pythagorean Theorem here, should just be 10 squared minus 4 squared. Which, when I type that in the calculator, is just the square root of 84, which is, to 3 significant figures, 9.17 centimeters. Let me show you one more. Question 8 here. Pyramid. The Great Pyramid of Cheops in Egypt is a square-based pyramid. The base of the pyramid is a square with the side lengths of 23.04, so it's square, so I just kind of put the congruent marks in there. And the height is 146.5 meters. And this M is the midpoint of side BC. Find the length of OM. So I'm trying to find this thing right here. Well, that's easy. That should just be half of the 230.4. It's just halfway across. So it's just 230.4 divided by 2, which is 115.2 meters. And to find the length of VM means I'm creating a right triangle here where I know the two sides. So I'm just going to draw this right triangle off on the side. I've got this as 115.2, this is 146.5, that's an M, that's a V, that's an O, and I'm trying to find the length of VM. So again, it's just the Pythagorean Theorem. VM is just the square root of 146.5 squared plus 115.2 squared. I'm adding them because I'm trying to find the hypotenuse. I'd subtract it if I was trying to find a side that wasn't the hypotenuse. And you type that in your calculator into 3 significant figures, you get 186 meters. Just like that. And that's about as complicated as it gets in this part of subtopic 5.4. The next thing we talk about is finding the angles, and that gets a little bit more challenging, but we will address that in the next video, so thank you for watching.